Okay, class, how you doing? This is 13.6, Law of Cosines. In this video, we're going to do two things. We have two objectives. First, we're going to use the law of cosines to find the sides and lengths and angle measurements of a triangle, just like we did with law of sines. In the second part of this video, we're going to learn how to use Heron's formula to find the area of a triangle. Okay, so the law of sines is basically this. We're not going to derive it in the video, it would take too long. But if you'd like to see this in class or you're curious, you can come by O Block, and we've had a few kids do this for the law of sines, and we'd be glad to show you a proof of this. But this is the law of cosines, and it's particularly useful if you have a triangle and you're given three sides. It's also very useful if you're given two sides and an included angle. So these are the two cases where law of sines would be difficult to use, or you can't use it, and then you'd use law of cosines. All right, let's jump right into an example. I put the law of cosines up here in the corner just to kind of remind me, I don't have to memorize this. Usually you see these formulas here listed on any type of standardized test. You always see these included in formula sheets and things. Now, if you look, we still have the same little a, little b, little c, and the big A, big B, big C. So the first question is, use the given measurements to solve the triangle ABC round to the nearest tenth. Okay, so if you see here, we're given what looks like to be an included angle. This looks like an sine angle side. Okay, the first thing I'm going to do to solve A, I'm going to label the triangle first. I'm going to call this A, B, and C, big A, big B, and big C, then little c, little b, and little a. So I have A to be 8, I have B to be 5, and the angle between them is going to be 32.2. Hope you can read that. And over here on the side, I like to kind of just put, just put everything I'm looking for and everything I have. Kind of makes it easier. I'm going to put A here, 5 here, and C we don't have. We do have the angle of C is 32.2. So to solve this, I'm looking for the law of cosines equation that I can use to solve. And it looks like the last one here, c squared equals a squared plus b squared minus 2ab times cosine of c would give me c squared, which is one of the sides I'm looking for. So I'll go ahead and use that. So if you multiply 2 times 8 times 5 times the cosine of 32.2, you get 67.7. 8 squared is 64. 5 squared is 25. And if you calculate this all out, you get c squared is equal to 21.3. Now to get c by itself, you have to square both sides. So the square root of c squared equals c equals the square root of 21.3. So you have to take the square root of 21.3. And you get 4.6. So c is equal to 4.6. 4.6. So I'll just fill in we'll fill in this spot here for little c is 4.6. And I'd also put it on the triangle here so you can easily see it. So now you need to find the other angles in the triangle, and now it might just be better to use law of sines, might just be a little bit easier. So that's what I'm going to do. Since I have the side little b and I have the angle C and the side little c, I'll set up a ratio that can solve for angle B. So the equation for angle B would be the sine of B. Remember, that's over the side across from it, which is 5, is equal to the sine of angle C, which is 32.2. So sine of 32.2 over 4.6. We just found that out. Little c is 4.6. We cross multiply. After we cross multiply, we'll divide both sides by 4.6 to isolate the sine of B. So when we do that, we get the sine of B is equal to 5 times the sine of 32.2 divided by 4.6. All right, so when we do that, we get sine of B is equal to 0.579. I like taking out the 3 spaces just to do it. And in your calculator, to find the actual angle of B, remember, you're going to use it looks like inverse sine, but it's not, but it just is. And you're just going to use that function on your calculator to solve for the angle B. So what you'll do is you'll hit the second button on your calculator, then hit the sine button. You should see the sine -1, then put in 0.579, close the parentheses, and you should get the angle of B is equal to 35.4. So then we have angle B is 35.4. I'll put it up here and squeeze it in here, 35.4. And the final thing is to find angle B. At this point, to find angle B, angle A, it'll just be easier to subtract the angles B and the angle C from 180. This is angle C. And so the angle of A is equal to 180 minus 35.4 and minus 32.2 is equal to. And so angle A is equal to 112.5. All right, so here are your answers. I'll highlight these. Here's angle A, angle B, we're given C, and then side C. Looks like. Here's another problem. This is part B. And it looks like here that we're given 3 sides. So I'm going to go ahead and label the triangle. I'm going to label the triangle A, B, C, and call little a 8, little b is equal to 9, and little c is equal to 7. Now, as soon as I find out one angle, I can use law of sines to figure the rest out. So I'm just going to try to find angle A. You could actually solve for any one of the angles, but I'm just going to choose the first one. So I know that a squared, I'm going to use the first formula here. And I know that a squared is equal to 8. So I got 8 squared is equal to b squared, which is 9 squared, plus c squared, which is 7 squared, minus 2 times b, which is 9, times a. Doesn't matter which one because you put first, you're just multiplying them, so just keep consistent. 2 times b, which is 9, times c, which is 7, is equal to the cosine of a. Okay, I just multiplied these out. And now I have to move everything but cosine A to the left-hand side of the equation. So I'm going to subtract 81 and 49. Then I'm going to divide through by 126 to leave me with cosine A alone. So if I subtract 81 and 49 from both sides of the equation, I'm going to be left with negative 66 is equal to negative 126 times the cosine of A. I'll just divide both sides through by negative 126. And I got cosine of A is equal to, it's equal to 0.524. Now remember, to solve for the actual angle of A, we're going to have to use it looks like the inverse cosine button on your calculator, though it's not, just finding out what the angle. And once you use that, you find out the angle of cosine is, when the angle of A is 58.4. So we're just trying to find all the angles. So the first angle I'm going to put up here, 58.4. Now we need to find the other two angles. And to find angle B, and you could use the law of sines at this point. I think it just makes it a little bit easier. So let's set up your law of sine. So the sine of A, which we found to be 58, over the side across from an 8, which is 8, is equal to, let's solve for C. The sine of C over the side across from it, which is 7. Again, I'm going to cross multiply and divide through by 8. And I get the sine of C is equal to 7 times the sine of 58.4 divided by 8. Now I did two steps there like we did in class. Okay? When you multiply that through, you're going to get sine of C is equal to 0.745. And remember, to find the actual angle of C, we're going to have to use what looks like the inverse sine button and put it into our calculators. And we're going to get the angle of C is 48.2. So we found the angle of C is 48.2. And all we need now is just to find the angle of B. And the angle of B is quite easy because we can subtract the other two angles, A and C, from 180. So 180 minus 58.4 and minus 48.2. That would give me an angle B of 73.4. So the angle of B is 73.4. All right, so we found all the sides. So we had all the sides. This is an SAS SSS triangle, and I hope this wasn't too messy. If you could please fill out a video form for this and do this problem here for practice. And then once you're done with that, finish with this problem here. Raise your hand, let me come up there and check your answer. Okay, thank you very much. One, last work. Once you're that I posted here, but I'll post this online as well. So